We're now live on YouTube to nobody. See how I repeat jokes? Okay. We're going to make a convection current, simulate convection currents in the mantle. I'm going to use this is called a micropipette. And I am going to very, very carefully target some dye right about there. That's okay. All right. I'm not worried about it. Okay. And now I'm going to take that's going to be really hot. Okay. I'm going to take my styrofoam cup here. It's actually not that hot. Now I'm probably in the screen, aren't I? I'm going to take my styrofoam cup here and pour some water into it. Okay. Yeah, that's warm. Okay. And we're going to put this, I'm going to set that down for right here. I'm going to take these ice cubes here, which I'm going to, oh shoot. Get out of there. Come on, get out of there. That's right. That'll work. In fact, here we go. It's no big deal. This is riveting TV, people. Oh, it's because, we've got a vacuum problem. There we go. Okay. So I'm going to set this right there very carefully. Good job, Ella. Okay. Now, I'm going to put this hot water right underneath this spot. No, it's not going to blow. It's not going to blow, I promise. Okay, we're going to lift that up just a tiny bit. Okay, now we will watch. Okay, the red, wow. The red, what's happening to the red dye because of that hot water underneath it? Don't think too hard. Go ahead and say it.
It's gonna move.
Go ahead.
It's gonna rise because of the heat from the hot water.
Right. So the hot water is underneath there. There's hot water, so it's constantly evaporating. Water's always evaporating, but hot water is going to do it a little bit more easily. That water is going to heat up the bottom of the glass dish in that spot. Okay? We've got an ice cube of blue water that is staying over here. And if you'll notice, what is happening to the blue water?
It's running out of the bottom.
Yeah, so it's sunk for one thing. Okay, we don't see too much blue water unless it's right here where this ice cube was put in. We don't see much of the blue water rising up. So it is sinking. But you can also see that it is going across the bottom. Okay? And now if you watch the red carefully, it's slow and it's subtle because that water is not super hot underneath, and it's not heating up that glass dish as much as this, or as easily as this is being cooled down. But we've got a definite convection current happening. Right. So as the red, and now you can really see it start to take off. Right there. Okay? That red food coloring is shooting up as it's being heated. It rises. It becomes less dense than the water around it. It rises, and the blue water is sinking. Okay? As blue water sinks, something has to go fill its place. And as the red water rises, something has to fill its place. And so you're just going to get an exchange or create this circular current that we call a convection current. And so that red water is going across the top of the dish. And that is a convection current. Now, if this happens in the mantle of the Earth, first of all, it's very slow, probably slower than this even. But what happens is you've got a crust. What we don't have in this demonstration is a crust sitting on top of this mantle. If the water represents the mantle, we're missing that crust. If we did put a crust on top of this, what do you think happens when there is this constant churning of liquid underneath that crust?
Oh, like similar to like volcanoes, basically?
Yeah, we'll definitely get volcanoes to pop up every once in a while. But what's going to happen to the crust itself? You want to try again?
Yeah, earthquakes?
Earthquakes, for sure. There's a lot of pressure from underneath.
It's gonna get wet.
Remember, it's molten rock. It's magma. It's okay, yes? Yeah, you will have, again, you will have volcanoes and stuff where hot magma is rising. But there's a lot of pressure pushing up. Think about it. It's not just pushing up on the crust. It's pushing up on the crust and moving this way along the bottom of the crust. It's going to move the crust. Okay? And what has happened to our Earth's surface is that it's been fragmented into what we call plates. And it's because of those convection currents down in the mantle. All that pressure pushing up on the crust and forcing those plates to move. Okay? Now, they don't move. You'll sometimes see convection current demos that show, like, there's a convection current here, and then one here, and then one here, and then one here. And so everything's all uniform, and you would think the Earth's surface would break all perfectly well. But convection currents happen randomly throughout the mantle, and they go in different directions. And so you have some plates that are moving some directions. You have other plates that are moving in other directions. Okay? But the basic force that's causing all of it is this. I love how if you watch the blue,
Just spun.
because it's a little bit more visible, yeah, it's spun, but you can just watch that blue dye just sink right down into the water, that denser, colder water sink to the bottom. It's pretty cool. And then the red come to fill its spot. Eventually, this will just become a purple mess as things mix up, but for a while, it'll be pretty cool. Yeah.
How do you get different size earthquakes, like 1.5 or like 9?
So it's just more pressure in certain places, and then eventually that pressure has to be released, and then that fault or wherever that earthquake is happening will be, usually it'll be kind of like, there'll be a period of time where its pressure has been released, so it's good for a while. I could think of all kinds of analogies. One really good one that I don't really want to say on camera. So maybe when I'll stop it, I'll share. Yeah.
This doesn't really have to do with this, but I have a question.
Yeah.
This,
Oh wait, it doesn't have to do with this?
no, it doesn't have to do with this, but it is kind of related.
Okay. Well, what is it going to be, like astronomy related or something?
No,
Should I stop this first?
no space.
Oh, okay. Well, I'm going to stop this. Okay. I'm not gonna take it off the screen because I want it to go the whole period. So, yay.